Alright, let's dive into something mind-boggling. Did you know that the world's biggest dark matter detector might just be the Earth itself? Yeah, you heard that right. Not some high-tech lab or a billion-dollar machine, but the planet we're standing on. Personally, I think this is one of those ideas that makes you stop and go, wait, what? It's like discovering your everyday coffee mug is actually a secret supercomputer. But let's break this down because it's not just a cool factoid, it's a game changer in how we hunt for dark matter. First, let's set the stage. Dark matter makes up about a quarter of the universe's energy content, and yet, we're still clueless about what it actually is. I mean, think about that for a second. A quarter of everything, and it's like the universe's biggest unsolved mystery. The leading suspects: axions and dark photons. Both are hypothetical, both are ridiculously light. We're talking 19 to 21 orders of magnitude lighter than an electron. To put that in perspective, you'd need a billion of these particles to match the mass of a single electron. What makes this really interesting is that these particles are so elusive, they've slipped through every detector we've built so far. It's like trying to catch a ghost with a butterfly net. Now, here's where it gets wild. The usual way to hunt for axions is to wait for them to convert into photons in a strong magnetic field. That's why scientists have built these massive, lab-sized magnets all over the world. But here's the thing, labs are tiny compared to the Earth. Atsushi Teruya and his team at Kyoto University had this brilliant realization: why not use the Earth's magnetic field? It's way bigger than anything we could build. And not just that, the space between the ground and the ionosphere acts like a natural cavity, resonating at around 8 Hz, the same frequency an ultralight axion would vibrate at. It's like the Earth is not just a detector but also an amplifier. If you take a step back and think about it, this is nature handing us a tool we didn't even realize we had. What many people don't realize is that this idea isn't just theoretical. The team didn't build a new machine or launch a satellite. They went to the British Geological Survey's Observatory in the Scottish Borders and analysed a decade's worth of magnetic field data that was recorded for completely unrelated reasons. They stripped out the noise and looked for a steady, narrow signal that dark matter might produce. And here's the kicker: they didn't find an axion. But what they did find was just as important. They set limits on how strongly axions can interact with light that are 100 times tighter than previous ground-based experiments. In my opinion, this is a huge deal because it's not just about finding dark matter, it's about redefining how we search for it. Now, let's talk about the dark photon search, because this is where things get even more intriguing. The team found some unexplained signals, and honestly, nobody knows what they are yet. The expectation is that they'll probably turn out to be something mundane, but what if they're not? What if, just maybe, these signals are the first hints of dark matter? This raises a deeper question: could the Earth, this massive, natural detector, be the key to unlocking one of the universe's biggest secrets? From my perspective, this is science at its most exciting, not just answering questions but opening doors to entirely new ways of thinking. Here's the thing: this research isn't just about dark matter. It's about how we approach science. Instead of building bigger, more expensive machines, we're learning to use what's already here. The Earth, with its magnetic field and natural resonances, is a tool we've been overlooking. A detail I find fascinating is how this team repurposed existing data to push the boundaries of what we know. It's like finding a hidden feature in a piece of software you've been using for years. What this really suggests is that the answers we're looking for might not require more resources, just a shift in perspective. So, where does this leave us? Well, we still haven't found dark matter, but we've taken a massive leap in how we look for it. The Earth, this giant, natural detector, has given us tighter constraints and a new way to think about the problem. And honestly, that's just as exciting as finding the answer itself. What makes this really interesting is that it's not over. Someone now has to follow up on those unexplained signals, and who knows what they'll find. Maybe, just maybe, the Earth has been the dark matter detector we've been searching for all along. As I wrap this up, I'm left with this thought: what other tools are we overlooking? What other natural phenomena could we repurpose to solve the universe's mysteries? Personally, I think this is just the beginning. The Earth as a dark matter detector isn't just a cool idea, it's a reminder that sometimes, the answers are right under our feet. Literally. So, what do you think? Is this the breakthrough we've been waiting for, or just another step in a much longer journey? Let me know in the comments below, and don't forget to hit that like button if you're as fascinated by this as I am. Until next time, keep looking up, or maybe down, at the wonders of the universe.